This is a pretty good problem, so I figure it's worth trying to solve. We have this, we're trying to solve the electric field at this particular point, and we have this distance from the x-axis over here, labeled as x. And then we've got basically a rod of infinite length going all the way to negative infinity and positive infinity, both directions. And we're trying to find the total amount of net charge that would be, from all these different points at the same time. And of course, we kind of understand that everything's going to cancel out except for the force that is in this direction only. And let's remember that the electric field is more like E equals K and then Q over R squared. And because we're looking at this particular direction only, we also know that it's supposed to be cosine theta. And now from here, we can say, all right, well, R squared, I suppose we can label R squared is supposed to be, actually, let's give ourselves some room because we're going to do some calculations here. But R squared is supposed to be x squared plus y squared, right? Because x squared plus y squared equals R squared. And let's think about y, because we have to actually integrate over theta here. We're going to be integrating over this particular distance, and that's going to be an angle from some kind of negative angle to some kind of positive angle. But we got to figure out what it is along this y-axis, right? What is y? Well, y could be represented as what is tangent? What is tangent of theta? Tangent theta is equal to y over x, right? Okay, cool. So tan theta is equal to y over x. That means that y is equal to x tan theta. Okay. And if we want to figure out what dy is, well, let's not worry too much about that. Let's just try to plug in y into this equation. So r squared equals x squared plus, this will be x squared tan squared theta. Then from here, we can say r squared equals x squared 1 plus tan theta. I guess it's tan squared theta. And of course, this is r squared equals x squared secant squared theta. And we're getting somewhere now. Because remember that dy is now going to be the derivative of this. So that's going to be x secant squared theta, d theta. And, well, we're starting to see some interesting patterns here, right? Okay, cool. So let's go back to our original equation. So we got k, and we got this q thing. We know we got to do the dq business, right? So let's deal with that then. dq is supposed to be lambda, right? Because it's just a linear thing. And then we're probably going to have, like dy, right? Lambda dy. So that's relatively easy, but we know that dy is this. So instead of putting dq up here, but let's just finish this off. We'll put r squared is this, x squared secant squared theta. We also know we have a cosine theta here. So things are going to start canceling out. It's kind of crazy. But this dq was supposed to be lambda dy. So let's put that over here. E equals k, and then lambda dy over x squared secant squared theta, cosine theta. And we know that dy is this. So E, hopefully I'm still on the screen here, E equals, okay, we got k lambda x, oops, not squared, but x, and then secant squared, and then we got a d theta somewhere over here. That's divided by x squared, a secant squared theta. And these will kind of cancel out. And then you're going to get E equals k, this is supposed to be a d over here. Once we started taking d's differentials on this side, we also had to take the differential on that side. I usually kind of just forget about that. Not too big of a deal. But anyway, k, and then we have, this is going to cancel out. So you get theta over x. And then, I also forgot the cosine. All right, let me stick that there. So it's cosine theta d theta. And so, yeah, you're going to get this cosine theta d theta stuff. Okay, and this is now what we can integrate, because we get E equals K lambda over X, and then the integral of cosine theta d theta. Our limits, we have to remember that if we're trying to take the limit of this thing, like, think about it. This can't really go past 90 degrees here, because otherwise it would start going this direction and it wouldn't even have contact with the wall. So it has to have a little bit of inclination just barely past 90. It can't go past 90. It can't even hit 90. If it was 90, it would be infinite. And it can't go that way in this direction. And 90 degrees is supposed to be pi over 2. So this theta has to go from negative pi over 2 to pi over 2. Otherwise, it won't even have contact with, like, there won't even be a line. So negative pi over 2 to pi over 2. And once you integrate this, this is just going to become sine of theta. You can, instead of saying negative to positive, you can cut this out, call it a 0, and put this over here, make that a 2. And so now essentially you would get that E equals 2k lambda over that thing. And then you're going to have the sine of pi over 2 minus sine of 0. And that's going to be your answer. Of course, this is just 1. So you're left with just that. And yeah, that's going to be the answer. E equals 2k lambda over x. This is pretty interesting stuff.